สวัสดีค่ะ Good morning everyone and welcome to our presentations. First of all, thanking all for taking time to watch our presentation video. Let me introduce myself. My name is Pathida Photdon and I am here with my team members. They are นัทวสาภูลสิงห์จิรวัตรจุลสำรวนนิชานันจินดามงคล and ทาเคชิตลาดเงิน We are first year students studying in Faculty of Food Industries from King Mongkut Institute of Technology ลาดกระบัง or KMITL in Bangkok. The purpose of this presentation is our faculty learn about foods and Thailand is an interesting agricultural products. The topic of our presentation is beer production from Thai rice. In our presentations, we will focus on 4 main parts. 1. Overview background of beer. 2. Methodology. 3. The result. And 4. Utilizations. Let's now begin with the first part.
Now, let's have a look at the picture. As the picture shows background of beer. What is beer? Beer is beverage made with water, grain, hop, and yeast. Beer is the oldest and most popular alcohol beverage in the world. It is produced from the fermenting of sugar, which derived from cellulose material. The most common material is barley malt and seasoned with bitter taste hops. However, wheat, corn, sorghum, and rice are also very used in conjunction with barley. Fermentation, when yeast is introduced into a solution of water and grain sugar colored wood. The yeast feeds on the sugar and the feeding process is known as fermentation. The byproduct of fermentation are alcohol and carbon dioxide, which make beer both alcohol and brandy. The process of brewing beer. Ingredient: water, malted barley, the starch salt, brewer yeast, hop. Process. Step 1. Malting. Malting is the process where barley grain is made ready for brewing. Step 2. Milling. Milling cracks the grain and make it easier for them to absorb the water that they are mixed with and with extract sugar from the malt. Step 3. Matching. Matching combines the millet grain with water and heat it in a methane. Matching takes 1 to 2 hours. Step 4. Rottering. Rottering is the separation of the wood, the liquid containing the sugar extract during matching from the grain. Step 5. Boiling. Boiling the malted extract. Colored wood ensures sterility during the boil hop and added with contribute bitterness, flavor, and aroma to the beer. Step 6. Fermenting. After the wood is cooled and aerated, usually with sterile air, yeast is added to it and it begins to ferment. Step 7. Conditioning. Conditioning can take place in the same tank as the fermenting. At this stage, the beer is cooled to allow freezing which settle the yeast and cause protein to conjugate and settle out with the yeast. Step 8. Filtering. Filtering the beer stabilizes the flavor and gives beer its polish shine and brilliance. Not all beer is filtered. Final step. Packaging. The beer is put into bottle, aluminum cans, and keg or black tank for high volume consumer. Now that I have given you an overview of background of beer, let's move on to the next part, which is methodology.
Now let's see the methodology of how to make beer from Thai rice malt by bottom fermentation. We found the interesting content from Dr. Chokchai Wanapool research. We partition into 3 parts as follows. There are 4 materials to produce beer in this process. First one is malt. Malt used in the research is GMO CP13 malt species. Next is hops. Hop is a flower of a horseradish that has the characteristic of giving a bitterness, which is a unique flavor of beer. Stop or enzyme activity from malt in boiling wood. Kill all microbes in the wood, including bacteria, fungus, yeast, that may cause smell that undesirable in beer products. Hop used in the research is Hostiner P90. Next is yeast malt medium food or shortly YM food. This consists of yeast extract, malt extract, and glucose. Last one is yeast. Yeast used in the research is Saccharomyces cerevisiae number 34. First, how to prepare wort. Firstly, bring GMO CP13 malt species that used in the research to mix with boiled water. This method is called mashing, in order to make enzyme to work by breaking the starch into maltose. Then, separating water from the malt. The resulting water is called wort. Boil wort for 1 hour and put the half hours. Secondly, how to prepare microbes. Saccharomyces cerevisiae number 34 is the name of yeast that used in the research. Fermented yeast by bottom fermentation mechanism. By put yeast into YM food, then incubate the fermented yeast. After that, bring the incubated yeast into centrifuge machine to separating the yeast. Last, feed that yeast by wort from step 1. Lastly, fermentation. Put yeast from the previous step into remaining wort. Mix together and ferment at temperature about 14 degrees Celsius. Marinate for 9 days. Then, take the beer that has filtered the yeast out and fill up carbon dioxide into the butter. Next part will be shown the chemical position and taste evolution of this beer from this resource.
Let's now look at the next slide which show result. Chemical property and volatile compound of final beer. Maltose was remained in final beer in the length of 2.3 to 4.6 gram per liter, while the inefficiency of maltose utilization was accurate in the 50-liter beer, which was the cause of residual maltose in final beer product from table 4.9. The amount of ethanol in beer was lower than standard commercial beer because of the lack of maltose consumed, then converted to ethanol, which was lower than standard commercial beer. Quantity of light malt ratio had an effect on both pH and color of final beer. High ratio of light malt influence on the higher pH value and higher color. High level of light malt and longer germination time improve the formation of estery compound in final beer. On 1, 3, and 5 days, the free fatty acid in beers. For the reason, the light malt contains the high level of fat, approximately 3%, which higher than fat from malt barley. Volatile fatty acid from the lipase during mashing step. The precursor of estery compound increases when longer germinated time and higher level of light malt was used. However, the residue of volatile fatty in final beer was the main cause of the off flavor in beer. Sensory evaluation of final beer. The sensory analysis test was completed by 12 assessors. There were 5 attributes required to evaluate, including appearance, aroma, flavor, mouthfeel, and overall impression. The appearance of beer was evaluated according to size, color, and clearance of beer. Let's move on to the next part, which is utilization.
Let's now look at the next slide which shows example of lye that is used of produced beer. Advantage of beer production from Thai rice can be applied to make semi-industry beer. Beer production using rice as the main raw material is aimed at reducing the cost of beer production, and for the value of Thai rice, the rice used in this study is mixed rice CP13, which the rice is transformed into malt, which malt from rice can be produced domestically, therefore can reduce the import of malt from rice. Barley encourages the use of domestic raw material that can be produced by themselves, promote the formulation and increase the value of agricultural products like our Thai Life. If our Thai Life is able to produce beer, then it tastes good. Then it can produce beer for export to foreigners. Those who benefit will be those who are able to produce beer, which may bring different types of Thai beer to produce better flavor. Next, I will pass you over to Patida, who is going to talk about conclusion.
Well, this brings us to the end of our presentations. In conclusion, we have given you overview of background of beer. After that, we have told you about methodology. We have also given you the result, and finally, we have discussed utilizations. We hope you will find our presentation useful. Thank you for watching. ขอบคุณค่ะ